morning. So today I'm going to break the lesson up into two parts so that you have time to work on your homework. So I'm going to just do, as far as the learning targets go, we're going to talk about how to make and interpret a dot plot, how to identify the shape of a distribution, and how to compare distributions. And that's mainly what we're going to talk about today. So just wanted to let you know how that's, which part we're covering. And then we'll get the other part tomorrow. So I'm kind of calling this 1.2a. So we're going to start with the dot plot, which is really a very simple plot. You don't have to start at 0 with a dot plot, but you do need to make sure that you don't skip. So for instance, our lowest point on here is 8.5, and our highest is 13. And so if I had a 27 on there, I would have to go all the way out and half size this to 27. I have to show the gap. Does that make sense? I can't skip. Now I can start somewhere other than 0, but I can't skip in the middle. Okay, because we want that gap to show, because that's how we show the distribution. So, so it says, how do you make a dot plot? First off, I've already drawn the horizontal axis for you. You just label that horizontal axis from the lowest data point to the highest. And then you literally just put a dot for each data item. Okay? So we're going to start off by labeling this from 8.5 to 13 in increments of 1/2. And ideally, you do that about the same distance apart, which is definitely not a strength for me, but we'll give it a shot. And then I definitely want to label the axis, and this is shoe size, so that's how I'm going to label my axis, shoe size. And that way the person who's looking at my chart knows what I'm looking at. And then the way I do this is as I get the dot, I just mark it off. So like for instance, 8.5, I'm going to mark through that and then put a dot for 8.5. Okay? And then now I want to keep like my first level all kind of the same across the board. So for instance on 13, I want it to be about the same distance away from the axis. So I'm going to put it about right here, hoping it lines up with that 8.5. Okay. And then my next one is 9 and 8.5. So I'm going to do 9. But then for 8.5, I already have an 8.5, so I'm going to do a dot above that one. And then I have 9.5 and 9, so 9.5. And then 9 would have to line up with that second row, because I already had a dot for 9. Does that make sense? And then 10 and 9.5, so 10 and 9.5. And then 9 and 11.5, so 9, I start my third row, and 11.5. I want to line it up with the first aisle there. And then 10, 10.5. So 10 and 10.5. And the last one is 9.5. Okay. Any questions on this? Pretty like basic, right? It's actually pretty simple graph. But it does show us a lot about the shape of the distribution, if there are any gaps, that sort of thing. And so that kind of leads us to talking about how do we describe the shape of a distribution, okay? Which is what I'm going to do next. Do I need to wait up for anybody? Are y'all all with me? Okay. All right, so let's talk about that. So for shapes of a distribution, there's 3 major shapes that we talk about. The first one is a symmetric graph. So that first one is roughly symmetric. That means, do y'all remember what the word symmetric means? I could fold it down this line right here, and it would kind of match up, if you will. And sometimes in statistics, if it's bell-shaped and symmetric, we call that normal. And we'll talk a lot more about that. For now, symmetric is great. The mean and the median, which we'll talk again in 1.3 about, are the same, or should be approximately the same if it's roughly symmetric. Okay, so I'm going to go ahead and write that in just because the more times you see it, the better. So the mean in this case would equal the median. Okay. Now, if on the second graph, if it's skewed to the right, kind of what that means is that if I were to kind of draw this out, the tail would be to the right. So most of the data is to the left and the tail is to the right. Okay, and so I always just think about if I'm trying to figure out the skewness, which way is the tail? Whichever way the tail is, that's the direction of the skewness. So this is skewed to the right. And in this case, the mean is going to be greater than the median. And then in the last one, I have a skewed to the left distribution. And that's because most of the data is up here, and then as you go down, you can see the tail is to the left. Another way to say that is it's skewed to the lower numbers. So like on a stem plot, when we hit that, it's going to be hard sometimes to tell because it's vertical, if it's skewed to the right or it's skewed to the left. So then you can ask yourself, where does the skewness go? Where does the tail go? Does it go to the higher numbers? And if it's to the higher numbers, you can say skewed to the higher numbers, which is the same as skewed to the right. And if it's to the lower numbers, you can say skewed to the lower numbers or skewed to the left. Those are the same thing. So this is skewed to the left. So what do you think that how the mean is going to compare to the median in this one? It's less than the median. So the mean, you might notice, kind of gets pulled towards the tail, and we'll talk a lot more about that as well. So far, okay? Okay. So when I describe a distribution, I'm going to use an acronym to help me with that. I'm going to look at the shape, the outlier, the center, and the spread. When I say outliers, I'm really talking about any unusual features, gaps, things like that. Okay, because sometimes it's not an outlier, but rather a gap. So like if you have a distribution that looks like this, then that's bimodal is what it's called. And there's a gap right in here. And so while it's not an outlier, we definitely want to talk about the gap that's in there, right? Because that's what's causing the shape to be bimodal. Okay. So we want to talk about any unusual features in that section. And so I have an acronym for this. I used to just do SOX, but I've added a C. And the C that's here is for context. So shape, outlier, center, spread, but I have to have it all in context. So when I say in context, what I mean is that my answer, when I answer it, I shouldn't be able to pick it up and put it as an answer to another problem. If I can do that, then I don't have it in context. Okay, and I'll show you what I mean when we do this next example. So in this next example, we're going to describe the distribution of our dot plot that we had in example 1A. So if we go back to 1A and look at this distribution, then you can see the shape. So let's talk about the shape on this one. What do you think? Skewed to the right, okay? So for shape, I'll just do it right here. You can do it on wherever in your notes you want to do it. If you want to do it in the packet where it goes, you could look at my picture and do it in your packet. The shape is going to be, so I'm talking about the shape of shoe sizes, right? So the shoe size, the shape of shoe size distribution is right skewed. Okay, what's the next thing I look at? Outliers. Okay. So do you think there's possibly an outlier here? Yeah, possibly 11 and a half and 13, right? 13 I'd be willing to bet money on. 11 and a half maybe or maybe not. We will have a very definite way of figuring that out. And when we hit 1.3, I'll give you a formula for finding out if it's an outlier or not. But for now, you could say possible outliers for shoe sizes 11 and a half and 13. Okay. And then the next acronym? Center. Okay. Now we're going to talk about two major types of center, median and mean. And I'm pretty confident most of you have talked about both of those before. But when we're looking at a dot plot like this, median is probably the easiest thing to look at. And there's 13 points here. Okay? And so if I divide 13 by 2, I'll get 6.5. And if I round that up, that'll tell me that the dot that's in the 7th position is my middle. Okay? Because there would be 6 dots to the left and 6 dots to the right of that point. Okay? Now if I had an even number, say 12, I'd divide by 2, I'd get 6, and my 6th and 7th dots, I would average those to find the center. And we'll do a lot more of that in 1.3. But just for now, we know it's the 7th dot. So we start at the lowest end and do 1, 2, 3, 4, 5, 6, 7. And so we can find that right there is our middle. And so median shoe size is 9.5. And then my next acronym is context. And so far, we'll go over context in just a minute. But the next one is what? Spread. Yeah. And for spread, there's going to be lots of ways we can measure spread, and we'll learn about that in 1.3. But for now, we're going to measure it talking about range. Okay? And so if we talk about range, anybody remember how to find range on a graph?
Biggest number minus
Yeah, right. The biggest number minus the smallest number. Okay, largest minus the smallest. And so the largest number here is 13, and the smallest is 8.5. And so if you subtract those, you get 4.5. And so we're going to say the range in shoe sizes is 4.5. Okay? And so then now if I check context, when I talk about context, which words do you think I mean when I say context? Shoe size, right. Shoe size is my key word here for context. And if you'll notice, I use that in all of these. And so all these places, I've got context. That's it. It's supposed to be an E there. All right? So now I know I've answered the question and I've done it in context. Does that make sense? Any questions? Okay. Okay, so we've talked about how to describe a distribution, but what if we have two distributions and we're wanting to compare them? So this becomes a little bit different because I kind of like comparing the distributions because you don't actually have to find the center or the range. You just have to compare them. So you could just say the range for one is greater than the range for the other. As long as you're using comparative language, then that's all you have to worry about. Okay? So when I say comparative language, what do you think I mean by that? Greater, less than, similar, equal, right. Not the same as, okay? Yeah, but you're going to have to be more exact than not the same as, probably. You're going to have to say which one's greater or smaller. Okay? Does that make sense? So comparative language. All right. So if we start with the shape of the distributions, what would you say about the shape of these distributions? We're looking at household size here, and they took 50 students from each country and compared the distributions of household sizes. Now remember, in some countries, they have their extended family all lives in the same house. So household size may include extended family, which is why some of these numbers are really big. Okay. So what would you say about South Africa? What kind of distribution do we have here?
Skewed to the right.
Okay, it's skewed to the right. Good. And then the UK?
Roughly symmetric.
Okay, so I heard two different things. I heard roughly symmetric and I heard skewed to the left. And actually, probably College Board would take either answer. If you said a little skewed to the left, because it's not like really badly skewed to the left, right? But if you said a little bit skewed to the left, or if you said approximately symmetric, you could probably get away with either of those, as long as you do it in context. Okay? So what I mean by that is we can't really use comparative language on shape, but we do need to use context. Okay, so here I've written the distribution of household size for the UK. Sample is roughly symmetric. They said with a single peak at 4, you don't really have to write that. You can just say roughly symmetric. The distribution of household size for South Africa sample is skewed to the right. They're really specific, said with a single peak at 4 and a clear gap. So I'm going to talk about all those other features in a minute. So if you just had this piece, the distribution, I can't do that on an outline, but the distribution of the household size for the UK sample is roughly symmetric, and then the distribution of household size for South Africa is skewed to the right. That would be enough. Okay? Notice I do have context there, though. For outliers, there don't appear to be any outliers in the UK distribution. The South African distribution seems to have 2 outliers. The households with 15 and 26 people. That makes sense? So outliers is where we talk about any gaps we see or unusual features, outliers, that sort of thing. And you don't have to copy this word for word. You can say, you can shorten it. You can say household size UK distribution has possibly 2 outliers. South Africa does not seem to have any. You're still getting context in there. So you notice there's not comparison language yet. It's when we hit center and spread that we have to have comparison language. Okay? So far okay? Can I move forward? All right, for center, now this one it actually states what the median is for these, but you don't have to do that. You can literally just say the median for household sizes for South Africa is larger than that of the UK. Period. You don't have to tell them what the median is. You just have to compare them. So for complete AP credit, you could say median household size for South Africa is larger than that for the UK. You can shorten that. Notice though I still have context and I still have comparison language. Okay? And then what's the last one that we're going to look at?
Spread.
Spread, okay? So when you look at this, what can you tell me about the spread?
Spread is greater in some.
Right. So when we talk about spread, in this case so far, how are we going to describe spread? With the range. So we would say the range in South Africa is what? Greater than the range of household size in the UK. Okay? And once again, they're more wordy and they actually give the range. But you can literally say household sizes for South Africa vary more or have a larger range than that for the UK. Does that make sense? It's actually kind of simple. You just have to have comparison language, have to have context. Oh, and you need to be right. You need to be making the right comparison. Maybe. All right, so notice that we have context and we have comparative language all the way through. All right, so we're going to stop here and pick up next time. So that was sort of a 1.2a lesson. We've talked about how to make a dot plot. We've talked about how to describe the distribution of when you have one dot plot or one set of data. And we've talked about how to compare distributions. Have a great day.